Okay, so hello everyone. We are here to present our domineering web-based AI-driven game. So this game is part of our Foundations of AI course. So in the next slide, I will describe about Domineering. So Domineering is a two-player combinatorial strategy board game played on the grid. The players alternatively placing dominoes which occupy two adjacent cells on the grid. So each player has their specific domino. Player one places the domino vertically, and player two places the domino horizontally. So the primary goal of our project is to create an AI agent which uses the min-max algorithm with alpha beta pruning to get the best possible move. So domineering is an example of an impartial game. So what is an impartial game? Impartial games are a class of combinatorial games where allowable moves depends only on the position and not on the current player who is playing the move. So impartial game possesses many properties, some of which are perfect information, that both the players have the complete knowledge of all state of the games, and there are no chance moves, and there are terminal positions for the ending criteria of the games. So for the rules of the games, the player takes turns placing dominoes in their respective orientations. A domino cannot overlap another domino and same extend beyond the grid boundaries. The game ends when there are no legal moves for any of the one player, and the player who cannot make a move loses the game. So next we will move towards the developmental framework for our domineering game.
I will be talking about the development framework that we used to build the domineering game, covering the technologies and logic behind its functionality. We started with the front, where we used HTML for structuring the game interface, CSS which styles the board, buttons, and overall layout, ensuring it's both functional and visual appealing. JavaScript to bring interactivity, allowing users to make moves. The game interface is responsive and dynamic, with CSS for clean visuals and JavaScript handling interactivity, including users' move, tone switching, and move validation. It also allows user to customize both dimensions using dynamic CSS grid properties and JavaScript for seamless adjustment. This combination provides a smooth and engaging experience for players. One of the most critical component is the AI logic, which we implemented entirely in JavaScript. We use the Minimax algorithm with alpha beta pruning to optimize decision making. This ensures the AI is both strategic and responsive, making the game challenging for players.
Coming to Minimax algorithm, it is a decision-making method used in two-player games. One player, the maximizer, tries to maximize their score, while the other player, minimizer, attempts to minimize it. It works by recursively exploring all possible game states to determine the optimal move. Each state is assigned a score representing the likelihood of winning from that position. Minimax evaluates the possible moves for the player and computer, determining the best course of action. Minimax with alpha beta pruning optimizes the algorithm by eliminating branches that don't influence the final decision. Alpha represents the best score the maximizer can guarantee, and beta represents the best score the minimizer can ensure. By pruning unnecessary branches, it reduces the computation requirement, especially for deeper levels of recursion. Alpha beta pruning helps the computer AI to make decisions more efficiently by evaluating fewer game states. So in our implementation, 0 indicates an empty cell, and V indicates player move, and H indicates the computer moves. This is the function named gate possibilities to gate the number of possibilities from the state where we are starting. Uh, The function alpha beta implements the alpha beta pruning algorithm to simulate possible moves. Depth is used to limit the AI's computation. Scores are calculated based on the difference in possible moves for the player and computer using the get possibilities function. The AI attempts to place its domino horizontally and evaluates each move recursively. It undoes moves after evaluating to ensure no invalid states persist. Next.
Now let us go through quick demo of our website. This is our website, Domineering Game. Here are the game rules, and we can change the dimensions of our grid from here. If we change 5 to 5 and 5 and set both sides, it will make a 5 cross 5 matrix. Here we can see whose turn is currently going on. Now it's player's turn, so I can place the vertical domino. Now computer turn over. Now again player's turn. So if I make the invalid move, if I make the invalid move, it will show invalid move, try again. Now player game is over, so computer wins. Again we can reset our game. Uh, these are the features we implemented: interactive GUI, customizable grid size, which allows users to adjust the matrix size as needed, strategic AI component, implements a smart AI for competitive gameplay. It displays pop-ups for invalid user moves, and it turns notifications, and that is, it shows messages indicating the current turn and declares the winner at the end. And we can reset the game for a fresh start.
Now, coming to challenges that we faced, there are three main challenges. Firstly, ensuring moves were valid and did not overlap existing pieces. So we implemented a place item function that checks the adjacency rules before placing a piece on the board. Next is the recursive exploration of moves required undoing each placed piece after evaluation. So we implemented a remove item function to clean up after evaluating each branch. Another one is the computer's depth setting that affected its performance and difficulty level. So we set the depth to 5 for the balance between challenging gameplay and reasonable response time.
We have tested with different depths in min-max algorithm with the alpha beta pruning, and we observed that when depth is increased, AI is taking more strategic moves, and we got the feedback from users as AI is making strategic moves and it's interactive user interface. Improvements in future. What we are planning to do is expanding AI difficulty levels to cater to a broader range of players. We are planning to add 3 levels, like for beginner, then intermediate player, then pro. For each level, we will use 3 different AI algorithms such that player can use. And we can include more efficient AI algorithms for more competitive play, such as Monte Carlo algorithm. And we can integrate machine learning to allow the AI to adapt and improve based on the past already played games by users. And we can add two human player option for increased engagement. And we can make the website responsive. We can deploy the website as well. Thank you.